Hey, this is Harry. This is Physics 2, Lab 5, Magnetic Braking with Faraday. Introduction. In this lab, I observed interactions of Faraday's law by dropping a magnet through a tube of aluminum foil and then modeling it using code. After I compared the experimental data, the results of the computational model. Some important concepts are Faraday's law, Lenz's law, Ohm's law, the Biot-Savart law, magnetic flux and force, and Newton's second and third law. Here are some important formulas that we'll be using. So checkpoints. Why can't we use a ferrous tube? We can't because it has iron and it become an induced magnet, which will skew the data from the falling magnet. For the second question, when comparing a magnet falling in free space with falling through the tube, the magnet takes longer to fall through the tube than in free space. So for the computational model, in GlowScript, I modeled this experiment. So in steps 1 and step 2, I initialized conditions using my measurements and previous data, like data from like lab 3. Step 3, I created a function to calculate magnetic flux. I also created a function to calculate it's called the magnetic field. Right here, I inputted the formula for the gravitational force. In step 4, I used Faraday's law to calculate the current in each ring. In steps 5 and 6, I used the Biot-Savart law to calculate force on each ring. And step 7, this is where I combined the gravitational force and magnetic force to the net force. And lastly, in step 8, I used Newton's second law, specifically the velocity and position update formulas to update the position and velocity. So this is how it is when I run it. Discussion part 1. So for the first question, using Lenz's law, red is counterclockwise and blue is clockwise. Red represents the current from the magnet and blue is the induced current. The combination of the two currents slows the magnet's fall. For the second question, the dynamics wouldn't change. The magnet would still fall slowly out the tube, only with the opposite current. So the third one, the results from both are pretty close. It'd be more accurate if the tube was modeled with more loops. If the fourth one, the shape tells us that the force of gravity is initially unbalanced, and then the forces from the magnet and gravity eventually balance out, which slows the magnet's descent until gravity takes over again once it falls out the tube. Discussion part 2. The first one, this will cause the ring's induced currents to greatly increase according to Ohm's law, which will make the magnet fall significantly slower or prevent it from falling completely. And for the last one, this will reduce the ring's induced currents, which in turn would decrease the magnetic force, counteracting the gravity, making the magnet fall faster. That's all.